Hello again, friends. Today in this video we're going to be talking about the comparison test. We're going to be trying to determine whether or not a series is convergent or divergent using our comparison test. So the one important thing that we have to know before using the comparison test is we have to have a stronger understanding of some of our more, as I'm calling them, known series. So for example, a geometric series, our p-series, our harmonic series. We need to have a understanding as what the forms of these series look like in order to be able to complete our comparisons. So the comparisons test states that if a known series converges, then our given series, so like our example problems that we have, the problems that we're trying to determine whether or not they converge or diverge, our given series then will converge when we know that the known series is greater than or equal to the given series. Similarly, if the known series diverges, then we know the given series diverges when the known series is less than the given series. So let's see how this works. So I have a series written down here, and now after maybe running through some other tests like the divergent series test, we see it's not divergent and not really sure what to do. So we come to the idea of, okay, let's try our comparison test. So the first question we have to ask ourselves is, what does this series look like? And if we kind of think about it, it looks similar to our harmonic series, which is equals 1, or it's 1 over n. We know it's divergent, right? Since we have ln over n, kind of looks similar to our 1 over n. So now we have to compare these series, right? So you have to compare the ln over n and determine whether or not that is greater than or less than our 1 over n. So this is our comparison. I'm not going to fit that in. Rewrite that. So as we have some nth term, ln of n, so sorry, our nth term here, right? So this is some term as we go into infinity. So if we think about like when n equals 1, we see that this clearly isn't going to be, this is, if n equals 1, we're going to see that this is a less than or equal to, right? Because we'll get 0 here and we'll get 1 here. However, like I said, we're looking for some nth term, so into infinity. So if we plug in some really huge numbers in for n, we're going to see that it's actually, why did I erase that? Let's see it's the opposite, right? We're going to have this be greater than or equal to. So what does this mean? We know that our famous series diverges, right? So our famous series is divergent. So, and since we know that our famous series, our harmonic series, is less than our given series, we know that our given series now is divergent.